Hi Algebra 1 students! Welcome to our first set of notes for our digital learning experience. Today we're going to be talking about section 9.3 in our book, which is simplifying radicals. If you remember, when we were still back in school meeting in person, we were talking about how to solve quadratic equations. In this section, we're not solving any equations. We're going to learn the skill of simplifying radicals. So that way in section 9.4, we can actually solve quadratic equations using square roots. So this is a good skill that we will be using and building up from after this section of notes. So I want to make sure that you are all still comfortable and able to do this once this note section is over. So if you noticed, when I posted this video on Schoology, I also attached a blank notes page for you. So if you're someone who likes to take notes along with me, which I highly recommend you do, you are welcome to print off this blank notes page for yourself so you can fill in the notes as we go. If you don't have access to a printer, but you're still someone who likes to write your notes down, no problem at all. Just grab a blank piece of paper and you can write along with me as we go. Now I'm probably going to break this up into a couple shorter videos because I know attention span wise people zone out on long videos. So we're just going to get started with a couple problems to begin with, and then I'll probably create like a second video for the last few problems just so that we're not completely spaced out at the end. That way you can take a break in the middle if needed. Okay, so our first problem to simplify a radical. What is a radical, you might ask? A radical is this square root symbol that we have on all of these problems on this page that you might see. Okay, so radical, the word radical is another word for square root. When you're taking the square root of something, that means you're trying to find two of the same. I'm here moving my hands. I just put up a 2 with my fingers like I'm actually teaching you guys. I miss it so much. So we're looking for 2. I guess I have to write on my screen. We're looking for 2 numbers that would multiply with themselves to get 36. So some of you might think, 6 times 6, well, that gets us 36. So when we take the square root of 36, it is 6 times 6 is 36. Another way of writing 6 times 6, you might remember, is 6 squared. So the square root of 36 is just 6. It's not the 6 squared, it's not 6 times 6. We're asking, what number can you multiply by itself to get 36? And the answer there is 6. Alrighty. Hopefully I explained that in a way that makes some sense. It's a little hard to teach when I don't have your faces to look at to know if we're getting it or not before I move on. But hopefully that made sense. Let's go ahead and move on to another problem where it's not a perfect square. So if you notice in problem 1, 36, a lot of you might have that memorized as a perfect square, which means an integer times itself gets us 36. Like 4 is 2 squared, 9 is 3 squared, so on and so forth. If we go over to number 2 here, the square root of 32, we don't have a number memorized that equals 32. Like, there's no number multiplied by itself that equals 32. So we have to think a little bit more creatively on this problem. So when we're trying to come up with numbers that multiply to 32, let's think of some numbers that they don't have to be anything special. We just want them to divide 32 perfectly. So one number that I think of off the top of my head is 4. 4 times something is 32. 4 times 8, right? I kind of feel like Dora the Explorer here. Like I'm kind of waiting for a response from you, but I'll never hear it. So I'm just kind of giving you some think time. But 8 times 4 or 4 times 8 is 32. We could even break these numbers down even further if we wanted, okay? Is 4 a perfect square? Hopefully you answered yes to that. Yes, 4 is a perfect square, so we could leave that one alone. What about 8? Could we break 8 down into any other perfect squares? You could break this into 4 times 2. Okay? 4 and 2, well, just the 4 is a perfect square. So we have 4 times 2 is the same thing as 32. So we could rewrite the square root of 2 as the square root of 4 times the square root of 4 times the square root of 2. The reason I can do that is because in my calculator, 4 times 4 is 16 times 2 is 32. So I'm still writing the square root of 32. I'm just writing it in a different way. But what is the square root of 4? Square root of 4, hopefully you're able to do that one, is 2. This square root of 4 is also 2. And that square root of 2 we're just going to leave alone. And if we simplify even further, what is 2 times 2? Sorry, there's a ton of 2's in this problem. 4. Alrighty, so our final answer here is 4 square root of 2. So that's how we simplify a radical when it does not have a perfect square in it already. Hopefully that makes sense. I'm actually going to stop the video right here and make a couple more that go along with this because I don't want to lose your attention span. So that's a good stopping place for you to learn how to do the first 2 problems on our notes page. And then you might have also, if you're looking ahead on Schoology, noticed that I gave you a 9.3 assignment. These first 2 problems on the 9.3 assignment look very similar to those first 2 problems we just did on the notes. So if you want to kind of multitask here, if you're able to do something like that, you might want to pause after this video and go ahead and do 1 and 2 on your assignment that you're going to submit to me before you move on to our next video.